real common thing as we're learning the derivatives is we know the derivative gives the slope of the tangent line at any point, right? So I can ask you to find the equation of the line tangent line at a given x value. And to get a line, remember from Algebra 2 and Geometry and Algebra 1, you need to have slope and a point. Well, I didn't give you either. I gave you a function and an x value. So you don't have a point yet, and you need the derivative to find the slope of the tangent line. So we got some work to do. When I see this, I know I need the point. First thing I want to do is plug 0 into the function. All right? I want to plug 0 into the function and find out that my point right away is at 0, -1. That's where this graph is located, all right? So I know that now. So now I know the point. Now to write an equation of the tangent line, I need the slope of the tangent line. To do that, I need what? The derivative. Do you guys agree? Everybody, quotient rule, right? This is a rational function, all right? Only interesting around the origin because it has a horizontal asymptote of 1. So I look at this and I go, okay, derivative of the top is 2x times x squared plus 1 minus, if I start pulling that out, 2x times x squared plus 1, right? Minus what? Derivative of the bottom, which is times the top, x squared minus 1, over the bottom squared. All right? So, if I look at this now then, don't simplify. Don't simplify, and I'll tell you why. What do we need to get out of this thing? We need y prime when x is equal to 0. Can I plug 0 into this purple disaster right now as it stands? Yeah, and if I do that, I don't need to simplify. I don't care. 2 times 0 is 0. 0 times junk is junk. 2 times 0 in the numerator is 0. 0 times junk is junk. 0 minus 0 is 0. The only thing I have to be sure of is what? That the denominator is also not 0. So I find that it's not. It's 1. So what's the slope? 0. So I go through point 0, -1 with a slope of 0. Everybody, hope you realize this is just a horizontal line, right? What's the equation of that line? Y equals -1. All right, y equals -1 is the equation of that line. That's the answer to problem number 1. Really quickly, if I move all this stuff a little bit to the side, and I make a picture, if you take your calculator, guys, make a graph of this one. Well, first of all, you know that it goes through -1 at the intercept, and it has a horizontal asymptote of 1. Everybody, look something like this. This function. It's pretty easy when you graph it to see that the tangent line is y equals -1. All right? All right. I'm going to pause here. I want you guys to try. We got a couple things to do here. First of all, we have to find the point or points, and then we need to find the derivative, all right, of that curve. It's not a function, so it'll have to be by differentials. All right, so I covered up some stuff, got the work done, so this end of the video will go fast. You might have to pause me to make sure you know what's going on. So I have this differential, this curve. It's not a function. So I'm at the differentials, and I say add x equals 1. Well, the first thing I want, if I want to do the equation of a tangent line, is have the point. 1 comma what? So I'm going to plug 1 into this function. All right? So I plug 1 in for y. For x, I mean, sorry. Whoops, and I guess I showed the answer there. See if I can get this down enough. My board's really being finicky. So I plug 1 in for x right here. And then I rearrange it, and I see that it factors. And that's wonderful, because then I find that there are 2 solutions for y, because it was y squared. So there are 2 points this time. 1, -6, 1, 2. That means I'm going to have 2 tangent lines at 1. And they're going to be different slopes. So I have points now. Now I need slopes, which means I need a derivative. So if I move the blue stuff off, I really don't need this, and I slide this down. Those are my 2 points now. I'll just keep them where I can kind of see them. First step is I see 1, 2, 3, 4 terms. 1, 2, 3, 4 terms. This is 0. The derivative of 13 is going to be 0. These are pretty easy. 2x and 2y, y prime. And then the middle term, 4xy, is a product rule. It's got x and y in it, all right? So I know there's going to be 4 terms on the left. We want to get to a point where we are not writing dx, but I'm going to write dx this time to help students out. So my derivative for this first step is, the easy ones are 2x dx for x squared, and 2y dy for y squared, and we know the derivative of 13 was 0. The harder ones are for 4xy. Derivative of x is dx, so you have 4y left, and the other product rule is derivative of y is dy. Now, on the long term, all right, for everybody who's doing this, you want to be practicing enough so that you get this in your head every time, and you're dividing by dx every time. And you'll notice if you divide by dx, anytime you took a derivative with respect to x, they just disappeared. And 0 divided by dx is just 0 here. So anytime you have a dy, it actually turns into just a y prime. So 2x plus 4y, 4xy, 4x y prime is this one. 2y y prime is this one. Now if it said find dy dx, I'd have to do some algebra. But I just want the slope at these points. I want the slope at 1, 2 first. I'll use the double positive point. I don't solve for y prime myself. I just plug in 1 and 2 for x and y. And when I do that, you can look at the steps here. I plug 1 in for x, 2 in for y, and I get y prime as negative 4/5. So now I have the slope, and I have the point slope form. And my first answer is simply y minus 2 equals negative 5/4 times quantity x minus 1. Then I have to rinse and repeat, okay, just like the shampoo bottle says, and find the slope of the last one. I do that using 1 and negative 6 into my red equation right here at this line, and I solve for y prime. And then I have to just write the equation again using the negative 11/4 of the point. This is a lot of work, guys, and you notice when I put it all up on the screen at once, it can be a little overwhelming, but it just comes down to practice. Again, finding the equation of the tangent line at a given x value.